This video will be about infinite geometric series. Remember that our formula for a geometric series sum was given by S equals g1 minus g1 r to the nth over 1 minus r. What happens if our sequence is infinite? In other words, n equals infinity, where we just keep multiplying terms and our series never stops. Then two possible things can happen. The first happens if the absolute value of r is greater than or equal to 1, and the second happens if the absolute value of r is less than 1. So let's look at the first case first. Let's think of an example of a geometric sequence whose r is greater than 1. Let's just say something like r equals 2, and we'll just say the first term equals 1. So our sequence is 1, 2, 4, 8, 16, and so on. If our series were to go on forever, meaning we add all of the terms of this sequence, then we can easily see that our sum is just going to get bigger and bigger until it reaches, in effect, infinity. So in other words, in the case where the absolute value of r is greater than 1, the sum is infinity. In the case where the absolute value of r is less than 1, we can come up with a sample sequence so that we can investigate. So let's just say r equals 0.1 and our first term equals 10. So this series would look like 10 plus 1 plus 0.1 plus 0.01 plus 0.001 and on until infinity. In this case, we can see that each of the numbers is getting smaller and smaller, so that the further you go down the series, in effect, the numbers that we're adding become 0. And this allows us to write a formula for the sum of these series, which turns out to be g of 1 over 1 minus r. So in our example here, our sum would just be equal to 10 over 1 minus 0.1, or 10 over 0.9, or 100 over 9. Using our formula for the infinite geometric series, we can come up with a way of converting repeating decimals into fractions. So a repeating decimal is something that looks like, let's say, 0.474747 all the way down, which can also be represented as 0.47 with a bar over it to indicate that it repeats itself. So what you can do is you split up this number into pieces. 0.47 plus 0.0047 plus 0.00047 and down. And you can notice that what we have here is a geometric series characterized by the first term equals 0.47 and common ratio is 0.01. Then we know that our sum is equal to g1 over 1 minus r, so that becomes 0.47 over 1 minus 0.01, or 0.47 over 0.99, or 47 over 99. And this means that 0.47 repeated is 47 over 99 as a fraction.